Well, good afternoon, everyone. My name is Chrislyn Particka, and I'm the project manager for the Northern Grapes project. And I'm also serving as the host and moderator, of today's webinar. So today's webinar is Northern Grapes project research results, fungicide sensitivity and vine nutrition of cold hardy cultivars with Patty McManus and Carl Rosen. Patty is a professor and chair of the Department of Plant Pathology at the University of Wisconsin-Madison. She has been a faculty member there since 1995, where her work focuses on the etiology and integrated management of diseases of fruit crops to the economy of Wisconsin. As a member of the Northern Grapes project, Patty has been researching the disease tolerance and fungicide sensitivity of cold hardy grape cultivars. Carl is a professor and head of the Department of Soil, Water, and Climate at the University of Minnesota. Carl is a soil scientist specializing in soil fertility and nutrient management for horticultural crops. He has extensive experience in soil and tissue test interpretation. His role in the Northern Grapes project has been to lead an on-farm effort in 5 states to determine optimal mineral nutrition and soil management practices for cold climate cultivars. Remember that as a participant in today's webinar, we ask that you keep microphones muted if you have them. If you are having any technical difficulties, please type a note in the chat pod on the lower right-hand side of the screen, and I'll do what I can to help. If you have questions for either Patty or Carl, type those in the chat pod as well. We'll take a break after Patty's presentation to address questions for her, and then we'll have time at the end after Carl's presentation for questions as well. So with that, Patty, I am going to let you get started.
Okay, can you hear me?
Yes, I can.
Great, good, okay. So, welcome everyone, and Chrislyn, thanks for inviting me. So this topic, I've presented on this topic before, and maybe some of you have heard me present on this before, but what's different today is that we really have all the data in, or at least all the data that we're going to get in for the next little while on this topic. We have 4 years of data to present, and so replication is really important in field research, and so it's, I'm really glad that we were able to have support from the Northern Grapes Project, sponsored by USDA, and then also North Central IPM to conduct this work. Next slide. Do I advance or do you do that, Chrislyn?
You do that, Patty, the little arrow at the top of the screen.
Oh, there it is.
The right.
Yep. Yeah, you told me that before, and I just, need a reminder. So 3 general topics today. I want to start out with just briefly talking about why we would want to use copper and sulfur for disease control in grapes. There's so many other fungicides out there. Why even bother with something if there's a risk that it might actually injure your plants? And then second, really the meat of the presentation is to talk about the results from 4 years. And then finally, to talk a little bit about if you do want to use copper and sulfur, how you would integrate these fungicides into a spray program. So today what I'm going to be talking about is really this is going to be an oral presentation of a newsletter article published a couple months ago. So if you do a search for the Northern Grapes News or plug in that title that I've circled, should be the very first hit that comes up. And, if you don't capture everything I'm saying today, you can either contact me directly or check out that newsletter article. And while I'm talking about the newsletter, if you're not aware of it, please do make yourself aware of it. There's always really good stuff in there. I've learned a lot about grapes and the other people working on grapes by reading that newsletter. Also, I have a graduate student, Dave Jones, who published an article, I think it was the last issue of 2015, on downy mildew. So Dave is working on, he's looking at disease resistance in the different cold climate cultivars. And so that was just a report from 2015 that he put in the newsletter. Okay, so copper and sulfur, why do we care on grapes? Well, copper-based fungicides are highly effective on downy mildew, and so that's the disease pictured in the upper right. That's actually downy mildew late in the season. Early in the season, it's kind of white and soft and downy looking, but later in the season, it looks more like stained glass windows. Limited activity on other pathogens against other diseases, copper. So really, downy mildew is the target for copper. Sulfur is highly effective on powdery mildew, but really has little or no activity on other pathogens. And so powdery mildew is the disease in the lower right. So both very common diseases wherever grapes are grown. I'm not going to talk about liquid lime sulfur, but I wanted to mention it just briefly because it is that time of year when some people are thinking about making a dormant spray for diseases such as anthracnose, phomopsis, and to a limited extent powdery mildew. And that's where either liquid sulfur or liquid lime sulfur come into play. Now, unlike copper and sulfur that can be applied after you have green tissue showing, every variety is going to get burned by lime sulfur, so do not apply after leaves emerge. So I just want to make that very clear. What I'm talking about today are copper and sulfur, not lime sulfur. Okay, well, we have reason 1 and reason 1 there. I don't know what happened there. I'm going to present 3 main reasons why you might want to consider using copper and sulfur for managing diseases of grapes. Now, the first would be resistance management to fungicides. So you may be very happy with your strobilurin and your sterile inhibitor fungicides, but they are prone to having pathogens become resistant to them. But copper and sulfur act by non-specific modes. They non-specifically disrupt proteins. And because it's some non-specific mode of action that requires many genes in a pathogen to overcome, they are still both quite effective after being used, even though they've been used for centuries on a lot of different plants. The second reason there, which is supposed to be reason number 2, would be that some forms of copper and sulfur are relatively cheap compared to synthetic fungicides. I think this is still the case for sulfur. It may not be so much the case for copper anymore. Its prices come up a bit. And then reason number 3 is if you are into organic production, then copper and sulfur are really going to be the backbone of your disease management program. And some, but not all, forms of copper and sulfur are approved by the Organic Materials Research Institute, or OMRI. If you are looking for OMRI-approved products, then copper and sulfur are often less expensive than other OMRI-approved products. So often less expensive than conventional fungicides, but often also cheaper than OMRI products. Okay, so now with that little bit of background, get into really what we did. So the impetus for this work was that if you look at extension literature such as the Midwest Fruit Pest Management Spray Guide, Michigan has a spray guide, Cornell does, lots of different spray guides, lots of different websites. Most of them, or many of them, will have a table, and you do not need to read this very busy table. That's not the purpose of this slide. But I just wanted to point out that most of them have a table where there's a bunch of cultivars listed, and then across the top, the different diseases, and then some chemicals such as sulfur, copper, 2,4-D, dicamba. And then listed are the sensitivity to either these chemicals or the susceptibility to different diseases. It's all well and good, but if we home in on cold climate varieties, what you see is a little bit of knowledge out there, but also a lot of question marks. And even where there is knowledge, most of those plus signs, most of those guesses, or maybe I shouldn't say guesses, maybe that's too harsh a word, most of those ratings come from research that was either not replicated or not set up in a statistically sound manner, or in some cases, some of those ratings are just based more on anecdotal reports and less on research. So the idea of this research, as well as our disease resistance work that Dave Jones, the grad student, is doing, is to try to remove some of these question marks that we see in extension literature. So our overall objective then is that we wanted to determine the relative sensitivity of northern varieties to copper, sulfur, and difenoconazole. I'll say a bit more about difenoconazole on the next slide. Before doing that, though, I do want to acknowledge that there are a lot of people involved in this. The main players were some of the researchers at our research stations affiliated with UW-Madison, Matt Stasiak, Brian Shoska, and Janet Hetke, and then in my laboratory, Victoria Cartanos and Dave Jones. And then there are various undergraduate students, too numerous to list. Okay, so difenoconazole. So I've talked a bit about copper and sulfur and why we're concerned about them. What about this fungicide? So this is a sterol inhibitor fungicide, a pretty good one, effective against black rot and powdery mildew. Well, those are the two main targets. But if you look at the label, you look under grapes, it says grapes except Concord, Concord seedless, Concord, and then you look over to the right and see some more precautionary measures. Okay, and then over there it says on Vitis labrusca, V. labrusca hybrids, and other non-vinifera hybrids where sensitivity is not known, the use of Inspire Super by itself or in tank mixtures with materials that may increase uptake, such as adjuvants, foliar fertilizers, may result in leaf burning or other phytotoxic effects. Okay, well, our cold climate varieties are all non-vinifera hybrids. I mean, they have vinifera in their parentage, but most of them have some labrusca and other non-vinifera heritage. So difenoconazole, I think I skipped over the top part here, but it's the active ingredient in Inspire, Inspire Super, Rebus Top, and Quadris Top. So a few fungicides that are out there. So we wanted to, while we were looking at copper and sulfur, see about difenoconazole as well. So our research was conducted at 2 locations. In the peninsular there, in kind of sticking out into Lake Michigan, is the Peninsular Agricultural Research Station, PARS. We have 2 vineyards there. One was planted in 2012 and the other in about 2007, I think. And then down in Madison, in the southern part of the state, 2 vineyards planted, likewise, one in 2007 and the other one in 2012. All told, we tested 15 different cultivars that are listed there. Not every cultivar was in every trial. So all of those were tested in at least 2 or 3 trials, or usually more than 3 trials, at least 2, but not all of them in every trial. I'll get into that a little bit more later. Okay, our treatments. So copper, sulfur, and difenoconazole for copper. A couple of different brands that we used, Cooperfix, Ultra, and then Champ, at the higher rate of the permitted on the label, and likewise microthol disperse, that was our form of sulfur at the higher rate on the label, and Inspire Super or Inspire. So we always went with the high rates because we really wanted to give the vines a challenge. And then of course we had to have a non-treated control, because what if things just started getting funky looking even though they hadn't been treated? We need to know, needed to have something there for comparison. Okay, so those fungicides were applied from 2 to 6 times each season at 2 to 3 week intervals, and this was from May until August. Obviously, if you only had 2 or 3 sprays, it didn't span that whole time. But some years well, in one year in particular, we had hail at the Peninsular Station, so we got 2 applications on, and then we completely lost every leaf on the vines after just 2 applications. We tried to have in most trials at least 4 to 6 times that they were sprayed, so pretty heavy doses of these fungicides. 11 trials total over the years, and a point I do need to make is that they were applied without adjuvants, so no spreaders, stickers, no uptake enhancers, anything like that, and they were not mixed with other pesticides. Now, we did have other fungicides going on there because we wanted the plants to remain healthy enough that we could actually do phytotox ratings, but they were never applied at the same time as the copper, sulfur, or difenoconazole, never in a tank mix. So the data that we collected was that about every 2 weeks we would go out and one person for any given trial, one person did all the ratings season long, and they would get a rating of 1 if we saw no visible injury, 2 if there was minor injury, 3 if it was a level of injury where you'd say, boy, there's something going on here, and if I were a grower, I think I would be getting concerned about this, And then 4 was where it was just a no-brainer that there was just a lot of problems going on. So we had replicates for each variety, and so we had to take averages, and so we would call it that there was a problem. We would call it toxicity if the average rating was greater than 2.5 and it had to be statistically different from the non-treated control. So as all of you probably know, grapes, certain varieties sometimes get little speckling and spotting called rupestris speckle, and that's why we needed to have controls in there. We needed to know if what we were seeing was something unusual above and beyond the background speckling and spotting. So just a few photos to give you an idea of what we saw. So this is late in the season. You can tell by the bird netting. Injury from copper on Brianna, and that was at Peninsular Station in 2012. You know, if pretty much every leaf on the vine had something like that going on it, and so that would we gave that a 4. Here was a little bit of copper injury on Marquette in Madison in 2013. Again, this was late in the season after a number of applications had been made, but only a few leaves on the treated vines had that that marginal yellowing, and so that was I guess I can't remember off the top of my head if that would have gotten a 2 or a 3, but not quite as alarming as what we would see sometimes. Here's some fauche that were sprayed with sulfur. You can see the marginal burning on some of those leaves. And then another demonstration of fauche sprayed with sulfur on the left cordon that was sprayed with sulfur, on the right cordon sprayed with copper at the Peninsular Station in 2012, where there was also some hot weather in 2012, which also can contribute to sulfur injury. So anyway, those are just some photos to give you an idea of what we were looking for and what we found. The next couple of slides are kind of busy, but this is where the real data comes in, or the summary of the data. Again, if you don't follow this, I have something very similar in the Northern Grapes newsletter, so be sure to check that out. What we have here are all the varieties that we tested listed, and then across the top I just numbered our 11 trials 1 through 11. If you want to know which year and which location the different trials were, check out the newsletter. But what I want to demonstrate here is that if you see a black box, that means that that variety was tested in that trial, and in fact there was phytotoxicity, so a rating greater than 2.5 and significantly statistically different from the control. If you see a gray box, then that means that the variety was tested in that trial, but there was no phytotoxicity observed. And if you see a white box, so a number of the cultivars more towards the bottom, there's lots of white boxes, that means that in that particular trial, it was not tested. So as I mentioned earlier, some varieties tested in all trials, some varieties tested in only a few. Okay, so copper. Brianna reacted the worst to copper, and you can see that there were phytotoxicity was recorded in 7 out of the 11 trials in which it was tested. In fauche, Maracel fauche, the second one listed there, 3 out of the 11 trials we had phytotoxicity, and likewise go down a little bit, 3 out of the 11 trials, Leon Malo, we saw copper toxicity that we thought was noteworthy. So a couple of other cultivars there, Frontenac, Front Gris, La Crescent, and St. Croix also have a black box or 2, but generally those are probably a little bit less prone to, or less sensitive to copper than Brianna, fauche, and Leon Malo. And so our recommendation from this is that if you have Brianna, I would say do not apply copper to it. We would get reaction from Brianna in some trials, not all trials. You know, some of this is weather dependent and depends on things that we probably don't understand. But in some trials, we actually had reaction from Brianna after just 1 spray. With those other varieties, my recommendation would be use copper with caution if you want to use copper at all. So restrict copper to just 1 or 2 sprays per season on Frontenac, Front Gris, La Crescent, Leon, Foch, Marquette, and St. Croix. So again, most of our reactions showed up after 4 to 6 sprays, but just to be conservative, just to play it safe, I would say restrict your copper spray to 1 or 2 on those varieties. Okay, for sulfur, the same story here, the same way to interpret the table. If you see black, it means that that variety was sensitive to sulfur in that particular trial. And gray means it was tested, no toxicity. White means it was not tested in that particular trial. Once again, the sensitive varieties appear to be Brianna, Foch, and Leon Malo. Now, we knew going into this that Foch and Malo, which happen to be siblings, we knew going into this test that those were sulfur sensitive. That's been documented. Foch is an older variety. So it was really nice, actually, that we had it in our trial because it acted as a canary in a coal mine for us in that if something was going to get damage, or if conditions were ripe for damage, then Foch was there to react. And so a couple of black boxes for other varieties, but really in let's see, I guess it's La Crescent and St. Croix, but only in 1 out of 11 trials. So a recommendation for sulfur would be that to not apply sulfur to Maricel Foch, Leon Malo, or Brianna. And to play it safe, I would restrict sulfur to 1 or 2 sprays per season on La Crescent and St. Croix. You know, keep in mind, my recommendations here are probably conservative because I don't want to say something and then have somebody use it and then get angry and, you know, tell me I'm a fraud and so forth. So these are conservative recommendations. You know, you go back and look at those tables, you can see that even though I have this recommendation for La Crescent and St. Croix, in 10 out of the 11 trials in a lot of different conditions over 2 locations, in fact, we didn't see issues. Another thing to keep in mind is that a little bit of phytotox, say a rating of 2.5 or maybe even a 3, that's a whole lot better than losing your crop or losing the whole canopy to downy mildew or to powdery mildew. In the case of sulfur, downy mildew in the case of copper, powdery mildew in the case of downy mildew in the case of copper, powdery mildew in the case of sulfur. So I'm thinking particularly here if you're an organic grower and you don't have a lot of options, just remember the little bit of burn is probably more tolerable than a whole lot of disease that's just going to build up and be with you in the following year. Okay, difenoconazole, I'm not going to show a table for that because there's not too much to show. Norier was the only cultivar out of the 15 that showed any sensitivity, and we only had it in 2 trials, so I'm a little bit hesitant to make broad sweeping claims. It was in 1 of the 2 trials, so you know, on the one hand it was only 1 trial, on the other hand 1 out of 2 is 50%. So I guess I'd play it safe with and perhaps not use difenoconazole on Norier. The other varieties that I've listed there were tested in at least 3 trials, and some of them in all 11 trials, and none of them were sensitive to difenoconazole. So we're kind of fortunate there. I guess the non-vinifera heritage did not harm these varieties too much in terms of their sensitivity. Okay, I am kind of running out of time, it looks like, but quickly want to just point out that if you have a good reason, or you know, before using copper and sulfur, you need to think, well, do I really need to? Do I have a good reason? I've already gone over some of those at the beginning, reasons why you might. We just talked about copper and sulfur sensitive varieties, so certainly consider that. But another important point for particularly for copper is to think about pH. So at lower pH, copper ions become more soluble, and this is when you can get burn on plants. And so remember, I said that we did not mix our copper or sulfur with anything. And so read labels, be careful that if you're using something such as phosphorus acid fungicides, that will make your mix more acid. Use copper with extreme caution. In fact, I would say don't use it if you're using phosphorus acid fungicides. If you need post-infection activity, then you probably will want fungicides other than copper and sulfur, and there are a whole host of them, not so much for organic growers, but for other growers that provide better post-infection activity. And then finally, I've alluded to it, but you need to think about the weather at the time of application and shortly after. And so hot temperatures are going to increase your risk of sulfur injury. Cool, wet temperatures are going to increase your risk of copper injury. We did not have any hot weather except in 2012 in Wisconsin. And so those of you from South Carolina, other places, but I think I saw quite a few people from Ohio and Indiana on the list. This may be something that's going to play out different in your part of the world. Weathering of fungicides, copper and sulfur are not well, sulfur is not tenacious. Copper actually is fairly tenacious. You can see all that blue residue in some of my photographs. But with sulfur, if you have a lot of rain after application, then reapplication is going to be necessary. So with that, I want to quit on time so that I don't run into Carl's portion. And I don't know if we have time or not, Chrislyn, for questions?
Yeah, we have a little bit of time. Tom had a couple questions relating to rain. Basically, how long can they be applied before rain and how soon after a rain?
Okay, so basically any fungicide, commercially available fungicide, once it dries on, it's going to be fairly rain fast. So how long before a rain? Well, I guess, and how soon after a rain? I'm not sure I'm understanding exactly.
I think maybe the first question was in terms of, like, because it's copper that can be more phytotoxic if there's water.
Oh, sure. Boy, yeah, don't have data on that. What I worry more about is prolonged wetness. So if there's going to be a period of 3 or 4 rainy, misty, rainy, misty days, foggy days forecast, that would not be a good time to apply copper. If it's a summer storm where it's here and gone, that's not going to result in toxicity most likely.
Okay. Well, that was the only question that we had, and since we are kind of short on time, Carl, well, Patty, thank you, first of all. Good information. And then, Carl, I have your slides pulled up, and I have you set as a presenter, so anytime you're ready.
Okay, I think I'm here. I was going to try to get this. It's all right. I won't use the, it's not working.
Okay.
There it is. There we go. All right. Well, good afternoon or good morning, depending on where you are. Thanks again for the invitation to give you a kind of an overview of our research on vine nutrition of cold hardy cultivars. And I also appreciate the support we received from USDA NIFA and the Northern Grapes Project to work on this. So, this has been a very large project. We've been working on it for 3 years now, and I do want to acknowledge that we could not have done this without our collaborators, Tim Martinson and Chrislyn Particka at Cornell, Paul Demoto and Diana Cochran at Ohio State University, Arlene Hutterman-Valenti at North Dakota State, and Rhoda Burrows and Ann Fennell at South Dakota State. So it was truly a joint project where they sent us a lot of samples over the 3-year period. Just to give you a little background for this research and why we conducted this project, a lot of the cold hardy grape varieties have been developed at Minnesota, and they have offered a lot of opportunity for winemaking in regions where typically it's been too cold to grow the grapes. And yet, because of that, we're using new background. For example, a lot of the background in some of these cold hardy varieties include Riparia, and we don't have a lot of the information needed to determine some of the optimal nutrition and soil management practices to determine how these might grow adequately or produce optimum wine. So what we want to do is look at some of the nutritional analysis that's been used as a diagnostic tool to determine what the optimal levels of nutrition are for these grapes. But as we've noted, a lot of these are based on varieties such as vinifera or labrusca, and we don't have a lot of data for any of the varieties that have Riparia in the background. So we wanted to see if that Riparia background made any difference in the nutrition diagnostic tools. So to give you a little more background in terms of determining optimum nutrition, we use tissue analysis traditionally based on petiole samples. And if you go into the literature now, even the use of petioles has come into somewhat of question, and some soil scientists and plant nutrition experts are recommending that blades can be used as well. So we wanted to take a look, took this opportunity to take a look at both petioles and whether the blade can tell us more information about the nutritional status of some of these winter hardy cultivars. So in some cases, the idea is that the blade tissue may actually be a better indicator of nutritional status. So a little bit of background just on petiole sampling. When is the optimal time to take it? Well, in most cases, bloom time or Varieties are the two times that have been selected, and there are advantages or disadvantages to each. The bloom time gives you, if you take it at bloom time, you can have a lot more growing season left to correct any issues that may be occurring. However, at the bloom time, the nutrient concentrations tend to be more unstable. That is, they tend to fluctuate more. They're changing. So Verizon has actually been the time that many recommend for taking because the concentrations of nutrients in the petioles stay stable, much more stable. And then we can use these values to predict the nutrient needs for the following year. The disadvantage of the Verizon sampling time is that if there are problems, there's little time left in the growing season to correct any of those problems. So we do have two times. We have two different diagnostic criteria based on those times, and they both have advantages or disadvantages. So Paul D'Amoto and I, this is a few years ago, we didn't have a lot of background data for the cold hardy cultivars, and so we kind of put together a table just based on what was out there. We looked at ranges based on Vitis vinifera and labrusca from both Western U.S. and Eastern U.S. Research, and we came up with a kind of what we consider sufficiency ranges for both the bloom period and the Verizon period. And you can see that the guidelines change dramatically depending on what time of the year or what time of the season you're taking that sample. And we'll get into this in a little bit more when we get into our research. So the overall objectives then were to establish or fine-tune some of the nutrient diagnostic criteria and interpretations for some of the recently released cold hardy grape cultivars. And then we took it one step further and we wanted to see if there was any relationship between some of the soil characteristics and tissue nutrient levels with juice quality. So we collected the grapes at the end to see what some of those juice characteristics might be. And when we looked at the tissue levels, we looked at the petiole, we looked at the blade tissue, and then we combined the blade and the whole and the petiole together to get a whole leaf value as well. So this study was, again, conducted over 3 years, and we had 16 sites in the original study. However, over the years, 4 of the sites were only used in the first 2 seasons, and a lot of this was due to either some cold damage or other unforeseen reasons that we couldn't include those 4. So we started out with 16, and we ended up with 12 in the last season. So we used 4-year-old vines of either Marquette, La Crescent, or Frontenac grapes, and it started in 2012. And these were monitored throughout the 3 seasons. We had 3 replicates in each vineyard of each cultivar. And so the original plan was to have 144 samples per cultivar over the 3 years. However, because of some of those problems, we had less than that. And I'll get into how many we actually used to help develop some of our new guidelines. So we also took soil samples from 0 to 8 inches and 8 to 16 inches, and we collected them in 2012 and 2015, and we characterized them for both physical and chemical properties. And we took leaf blade and petiole samples in 2012, 2013, and 2015. Note we skipped 2014 because there was a pause on this project and we didn't have the funds to analyze the tissue that year. Turns out that 2014 was a really tough year in the northern climate, so it was probably good that we didn't have that year anyway. We took samples at full bloom, and then midsummer, which was full bloom plus about 30 days later, and then Verizon. And then because of the time limitations, I'm only going to talk about full bloom and Verizon analysis. So this is how we did the sampling. This is at full bloom, and the recommended tissue to sample was either the leaves or the petioles opposite and of the bottom flower cluster. So you can see on this particular slide here, this is the shoot, and right where this finger is a little dark, but this is the leaf right here that was taken, leaf and petiole, for this particular sampling time. And then midsummer and at Verizon, the tissue taken was different. We take it at either the 5th or 7th leaf from the terminal. And here again, there's the shoot, and this is these were the leaves that were taken. And to show this a little more clearly, again, here is the shoot, and with the leaves identified that could be taken for that tissue analysis. So this is the 5th from the terminal, the 6th, and then the 7th. So moving on with the approach, so we took soil and tissue samples, and these were sent to a commercial lab using standard analytical procedures. And then at harvest, we took great yields, and they were either measured directly or estimated from cluster counts. And then we also took a subsample of grapes from those yields, and we froze those, and then they were analyzed for various juice quality parameters. These include Brix, pH, and titratable acidity, and then YAN, or yeast assimilable nitrogen. So this is getting into how we analyze the data now. And so we only took, for the diagnostic criteria that we were trying to modify or develop or fine-tune, we took data only from the vines that had adequate yields. So they had to yield at least 4 pounds per vine. Went up as high as 39, but that was not very typical. So we were in that, usually more in that 4 to 20 pound range. And then we eliminated the highest and lowest nutrient concentration for each cultivar, and just to kind of get the two extremes out. And then he also excluded vines if they were recovering from frost damage, or if for some reason we didn't get any yield data provided for those vines, and if there was any nutrient stress that was evident in the vines. And there were a few vineyards that did have potassium deficiency. There was one vineyard that had some iron deficiency. So if they had those problems, then we would eliminate those from the analysis for developing the diagnostic criteria. So with the elimination and some of the vineyards that kind of dropped out, we ended up having 62 replicate years for Frontenac, and this represented 6 to 8 vineyards each year. And then we had 75 replicate years for La Crescent. This was 7 to 8 vineyards for each year. And then finally for Marquette, we had 80 replicate years, and this represented 9 to 10 vineyards each year. Okay, so what we then did was we took all of that data. We looked at the mean, the standard deviation, and the minimum and maximum nutrients concentration for each cultivar separately, and then we combined them for all cultivars. The concentrations that I'm going to present and the ranges are based on all the cultivars combined. So basically we have the mean that we're going to give it minus 1 standard deviation, and the mean plus 1 standard deviations. And what we found is that there was not a lot of difference among the cultivars. There were some minor differences, but I'm not going to get into some of those details. So what you're seeing here is a combination of all the cultivars. Just to give you an idea of some of the soil properties of the 16 sites, this gives you the mean values going from pH, organic matter, phosphorus, potassium, magnesium, zinc, and boron. You can see that the pH was, for the most part, in the slightly acid range, but we had quite a range going from very acid all the way up to very alkaline. Organic matter is 3.1. Again, a range from 1.2 to 5.7. So that gives you an idea. We also our texture went from a loamy sand to a clay loam. So we had quite a range in soil properties. So these are the results of our diagnostic criteria. This is the tissues that we sampled at bloom time. Okay, so what we have here are the elements that we analyzed here, and then we looked at the petiole tissue, the blade tissue, and then a combination of leaf and petiole, which we call the whole leaf. Okay, and one of the interesting things, there are 2 nutrients where, depending on whether you do the petiole versus the blade, it makes a really big difference. If you look at nitrogen in the petiole, you can see the values are much lower than if you're analyzing the blade or the whole leaf. And if you look at the blade and the whole leaf, those values are very similar because the blade tissue itself kind of, the biomass of the blade kind of dwarfs the biomass of the petiole. So mostly what you're seeing in the whole leaf is the influence of the blade tissue. But it does change slightly because the petiole can change. The other nutrient where it makes a very big difference is potassium. You can see much higher levels of potassium in the petiole tissue than you do in the blade or whole leaf. So again, the tissue, the table where the diagnostic criteria come from, you have to make sure that you know what tissue you're analyzing and what table that is, what that table that refers to, because the numbers will be different, particularly for nitrogen and for potassium. So these are kind of the data that we we collected. You can see going down from macro and micronutrients, we have a fairly complete set. And if you noticed in the first one that Paul and I worked on, we didn't have any data for sulfur. And so now at least we have some data for sulfur to add. So this is the tissue at Verizon, and you can see again the same trend with nitrogen, where the petiole tissue was much lower in nitrogen than the blade or whole leaf, and the potassium was much higher than in the petiole than the blade or whole leaf. You see some minor differences with some of the other ones, but again, you have these diagnostic criteria, which are slightly different than what we found with the survey that Paul and I did earlier on. So we are planning on doing a little bit of fine-tuning. We still have a very large data set. We're still kind of working on it. So kind of consider these tables as kind of preliminary at this time. Okay, moving on to what the relationships are between the nutrients, the tissue nutrients, and juice quality. We did an analytical procedure to kind of look at the relationships over each year. We looked at the relationship within each cultivar and each year. And what I'm showing you today are the consistent effects that we found over cultivar and over year. So we looked at significant effects if there were no interaction between cultivar or year, and the trend was the same over each cultivar across all years. Okay, so these are kind of the general effects, things that apply to all the cultivars over all the years. So relationships with yeast-assimilable nitrogen, what we found, and this is not too surprising, is that yeast-assimilable nitrogen in the juice increased with increases in tissue nitrogen. So we found the strongest relationship with the nitrogen concentration in blades sampled at bloom time. And it was, the relationship seemed to be higher when we looked at the blades rather than the petiole. That kind of makes sense because the tissue levels of nitrogen in the blades are much higher than in the petiole. We also found that yeast-assimilable nitrogen increased with bloom blade and whole leaf sulfur and Verizon petiole sulfur. So sulfur was positively correlated with nitrogen, so we kind of got this kind of a similar relationship with yeast-assimilable nitrogen as we did with nitrogen, with sulfur as well as with nitrogen. For juice pH, we found that juice pH increased with increases in bloom petiole potassium, and we found higher potassium in the petioles than blades. So again, kind of the opposite of what we found in the with nitrogen and yeast-assimilable. And petiole was better for juice pH than the blade tissue. And then juice pH increased with Verizon whole leaf nitrogen, and we did see some weaker effects for blades and petioles separately with nitrogen. And juice pH also increased with increasing yield per vine. With titratable acidity, we found titratable acidity increased with increasing bloom blade and whole leaf sulfur. And the mean sulfur concentrations was highest in bloom blade. So this is a similar response to what we found with yeast-assimilable nitrogen and blades, higher nitrogen in the blades. So we also saw an increase in bloom petiole phosphorus, increase in titratable acidity with bloom petiole phosphorus as well. Interestingly, with sugar or bricks, we saw some within each year, with each cultivar, we sometimes saw some relationships, but we didn't see anything consistent over the 3 years that we did the study. And, you know, in a way, it's not too surprising because juice composition, including sugars or bricks, is related to other management factors, things like cropping levels, fruit exposure, pruning, training system, and harvest timing can all interact. And so, so it's not too surprising that just looking at nutrients, the correlations were not that strong and for some of these juice quality parameters. So just to kind of summarize in terms of what we've learned so far, we had a very wide range of soil properties that we had in the vineyards that we studied. There was a wide range in tissue nutrient levels as well. We summarized the petiole and the whole leaf and blade levels based on previous studies with petiole diagnostic ranges that we have. We think we're going to have to do a little bit of fine-tuning for nitrogen, phosphorus, potassium, sulfur, calcium, and iron at bloom. And these at Verizon, we have a few more. We had manganese at Verizon. It's not going to change dramatically, but it's just going to be some fine-tuning based on what we've found. In terms of juice quality and nutrient relationships, we found that the tissues collected at bloom seem to be a little more predictive of juice quality than those collected at Verizon. We found that tissue nitrogen and sulfur influences juice yeast assimilable nitrogen. Tissue potassium and vine yield influence consistently juice pH, and sulfur influence juice titratable acidity. We did not find any consistent effects on Brix or juice sulfur related to nutrient status. So our most robust result is that there's a positive correlation between tissue nitrogen and yeast assimilable nitrogen. Not too surprising. One of the things to keep in mind that growers often base their harvest times on other variables, so they'll base the harvest time on the Brix or the pH and the TA, and so it's not too surprising that these variables may not be responding strongly to things like nutritional status because of the time these can change within a harvest window timing. So we're still, I want to kind of emphasize that we're still analyzing the data. It's still in progress, so the data that I'm presenting today should be considered preliminary, but I think we're really coming up with some new information for some of these cold hardy cultivars. So with that, I think the last slide is the last slide, and if there's any time for questions, I'd be happy to take them at this time.
We don't have any questions yet, but generally people start typing them now. So okay. we'll give it a few minutes and see if any come in. Just want to go ahead and take the opportunity to thank you, Carl, for your presentation.
Sure.
I am going to post, go ahead, and while we're waiting for questions to come in, okay, it looks like someone started to type in a question but didn't get everything. Oops, wait. Okay, never mind, sorry. We do have a question. Kathy asked if you could please define blade again.
Okay, so the blade tissue is the portion of the leaf that doesn't include the petiole. And the petiole is the leaf stem. So when you take a petiole sample, you normally discard the blade tissue. And when you do a petiole sample, you're just collecting the petioles, and then those go to the lab for analysis.
There we go, Carl. I pulled up the picture that shows.
There it is. There's the blade right here.
Oh, wait, you don't have control of those.
I don't have control.
So the petioles are in the palm of the person's hand, and the blade is what he's pinching between his finger and thumb.
Right.
So, okay. Let me go. We have a few more questions. Okay, Cliff asked, will recommendations be developed based on the tissue sample results?
Yes, that's the idea, is we are going to kind of fine-tune what we already have, and we will be taking what we found in this survey and kind of adjusting those values slightly. So that's kind of the idea.
Okay. And then let me go back here. Patrick asked, were any of the sample vineyards organic, and if so, were there any major differences in nutrient levels like yan?
As far as I know, none of the vineyards were organic, and so I think they were all pretty much conventionally managed. So, so I can't really comment on if there'd be any difference between organic and conventional. Although generally, I would think that in terms of the diagnostic criteria, it's probably not going to make any difference whether the nutrients are coming from an organic source or a conventional source. It's still going to have that same effect on the tissue composition.
I guess one question kind of related to that could maybe speculate, have you looked at, since you do a lot of other work on other crops with soil science, have you noticed any differences between a conventionally managed and an organic managed field of any other crop?
Well, yes and no. I mean, it really depends on, I mean, definitely you're going to see differences, and it depends on how well they're managed. Many times in organic situations, if you don't have the right compost, you can run into nitrogen deficiency. Alternatively, if you're adding too much compost, you're adding a lot of nutrients, and you might be in the excessive range. So there's, you can see it both ways.
Yeah, I didn't know if there'd been any controlled studies where they like took the same, soil plots in the same field and managed some plots.
Well. Yeah, and
that's going off at a tangent, though.
Yeah, you could have a long debate about that one.
I figured. Okay, we'll move on. Larry asked, do you have a correlation of nutrient analysis results to application rates of nutrients needed per acre, or general amounts of NPK needed to be replaced each year?
That's a really good question. We do have recommendations based on nutritional levels. In this particular study, though, we didn't really try to calibrate that. So we do have recommendations based on that. And in a more general talk that I'd give, I would go over, if you're at this level of tissue analysis, this is what we would recommend. But we do have that, and that's something that will be, when we write the final report, we'll have some of those suggestions in there based on the tissue analysis.
Okay, and then Cliff also wanted to know when or how will the recommendations be communicated?
Well, I guess the end of this project is in August, so we plan on working up the data through that time, and then I would say within the next month or two after that, we should have some pretty finalized data available. I will try to get some of the data out. I guess there is another newsletter. We'll try to get some of that out at the end of July or early August, and then kind of finalize things within a month or two after that.
Yeah, and just a note for everybody, this is like as far as results from the project in general, we are going to be publishing what we're going to call the owner's manual. It'll be an online only sort of thing, like our newsletters and progress reports and all that have been. And it's basically going to be like one of our yearly progress reports, like if you looked at the year 4 progress report, just beefed up a lot more than that. So all the data from the entire project with kind of some text that summarizes, like with the training system studies, we've done a lot of those, so it'll have some text that summarizes the training system studies in all the different locations. So all the data will be published at some point. I would expect that owner's manual probably won't come out more towards the end of the year, though, because a lot of people are continuing to do some research over the summer, and so we have to give them time to get it collected and analyzed and written. So anyway, look forward to that. More questions. Aaron asked, do you have a rough timeline of the recommendations or the changes? I guess we kind of covered that already.
Yeah, kind of covered that, yep.
So, all right, and then Dennis asked, were nutrient levels adjusted in the vineyard during the test period?
So, what we did was we allowed these were all pretty much on-farm vineyards, practicing vineyards. we did not try to adjust any of the levels, so we left that up to the growers. And so whatever they did is what we monitored, and just to get kind of a diversity of what was going on. So we should be able to get what those practices are, but we don't. We didn't try to control any of those practices.
Yeah, like for example, the vineyard that Tim Martinson and I took samples in had a potassium deficiency, and so he was trying to correct that during the course of this.
Right.
So, yeah. All right. Well, Carl and then Patty too. Thank you guys both for your presentations. We have gotten through all the questions, and it's just after 1 o'clock. So I think we'll go ahead and wrap it up now. So again, thanks to Carl and Patty, and thanks to our participants in the webinar. It's always great to have you guys online and asking questions. It definitely makes it more interesting. Finally, I have posted a link to a short survey. It won't take you any more than like 2 or 3 minutes to go take that survey, just some quick questions about today's webinar, and I do use your feedback in our reporting to the USDA and things like that, so I really would appreciate it if you go take that survey. So again, thanks everyone.
Thank you, Chrislyn.
Yep, thank you.